GPM will help us to understand precipitation extremes. And this is everything from too much rainfall, such as flooding in India or Southeast Asia, to too little rainfall, such as drought in the US Southwest.
There's about one major flood a day someplace in the world. So it's not as if it's a rare event. Big problem is that over much of the world, the in situ data, the gauges and the measured precipitation just isn't available. To predict floods, you need to have the data in near real time. And so the satellites are about the only way, GPM is about the only way that this is going to happen. And so we're going to use GPM rainfall retrievals to go do analyses, do flood forecasting, and bring climate services, bring information to users in these areas.
Landslides happen all over the world in nearly every country, and they cause more economic damage and more fatalities than people generally think. The large majority of landslides around the world are triggered by intense or prolonged rainfall. A landslide is a general term often used for mudslides, debris flows, rock falls, and usually it's just a mass of rock, earth, and dirt basically moving down a hill slope. Typical landslide studies are done at the local scale and they use gauge data. Now this is a problem in areas of topography where we don't have gauges or radar, and particularly in developing areas where we don't have any information. So satellite data is really important for understanding where and when this intense rainfall might happen that could trigger landslides.
In the western U.S., we deal with drought on a regular basis. It tends to be cyclic. We'll get 2 or 3 year dry years and we'll get a few wet years. If somebody could predict when the dry ones are coming, we'd be a lot better off. A lot of our water here comes in snow. It accumulates up in the mountains in the wintertime, runs off in the spring, and that's what we use for irrigation in the western U.S.
Agricultural drought is defined as a lack of water within like the top meter of soil for adequate crop functionality, so adequate crop productivity. And if you're talking about agricultural drought, probably the biggest error source is the quality of the precipitation information that you have available. If you have good precipitation information, you can do a very good job of characterizing drought and often its subsequent impact on agricultural productivity.
We do work in research in determining the water needs of crops and what the impacts on crops are if you don't have enough water. We're doing this because we realize that in the western U.S. there will likely be less water available in the future than there has been in the past, and the farmers need to know how to respond to that decreasing water supply. Certainly when we're looking nationwide, the better prediction we have of how much rain we've been getting and how much is likely to come in the near future is very, very important. To the extent that we can predict that with satellites, it's really beneficial. And this isn't just a U.S. problem, it's a global problem. Many countries of the world are facing the same kind of issues that we are. And so we expect this information to be able to be used in the East, in the western U.S., and globally.
We need accurate and timely rainfall information to understand disasters like floods, droughts, and landslides. GPM's global rainfall data will help us to better understand and model these types of disasters around the world.